Welcome back to day 10 of our program, where we're using all 10 of our fingers today. So stay tuned for what happens tomorrow. So for today, we're going to look at what is the total liquidity of the pair and the slippage. And without further ado, I will hand it over to Andrew.
Oh, query 10. So today we're finally getting into the concept of slippage, which I'm sure you've probably heard the term thrown around. So let me just walk you through this. So we're going to start by taking reserves. This is the same thing we did over here, but instead of just taking the last or the most recent reserve update, we're going to get all of the reserve updates. And what else we need is we need the swap price, which we can calculate from reserves. And then we want to simulate a swap both ways. So that's going to be simulating 1,000 USDC swapped and simulating 2 ETH swapped. Let's do 2,000 USD. So when you simulate a swap, you're basically saying, okay, I have some X in and a quoted Y out, but the price moves along the curve, XY equals K, before the swap occurs. So Y out will always be less than quoted. This difference between actual and quoted is the slippage as a percent. To get this, we're going to have to figure out a slippage formula that accounts for the 0.03% fee, which I will show later on. And ultimately, we'll end up with a time series of daily slippage. Cool. So let's save this. Day 10. Total reserves and slippage over time for USDC WETH. And with this, we can get started with the query. So first thing first, let's look at yesterday's query. And let's take the reserve data. All right, I'm going to take this portion here. We're going to use a CTE that we're just going to call reserves as yada. I don't want all pairs. I only want our USDC pair, right? So that's where contract address equals pair address, which we can go and find from one of our previous queries. Let's go here. Copy, paste this over. Okay, so we don't want this row number thing. We just care about the reserves over time. Let's start by truncating the date to, let's say, day. All right. And what we can do on top of this is say select all from reserves. And we want the median reserve. Let's say, actually, you know what? Let's do this as the last reserve of each day. So we are going to keep the row number, and we're going to partition by pair, and we're going to order it by, let's do this, descending. Actually, we're going to partition by pair and also by the day. And then we're going to order by the block time descending as last. Sync. And we're going to select from here where last sync equals 1. So we want the last sync of every day. Let's run this and see what we get. Okay, so we have our results here. And let's just see if this looks right. So this is reserve 0 over time. This looks fairly correct. And if we wanted to see reserve 1 over time, obviously we have to remove reserve 0. All right, this looks good enough. I'm not seeing any random spikes in the data, so I'm comfortable with this. So now let's also put in our simulated amounts. So that's going to be 1,000 as amount 0 simulated, and that's going to be 2 as amount 1 simulated, right? Where we know that token 1 is WETH and that token 0 is USDC. And if you're wondering how I know this, I can just go to Etherscan, plug in the contract, go to the read function, and look at token 0 and token 1. And I recognize that this address is USDC and that this address is WETH. Right. We know this. I have the amount simulated in here, and I am going to move this in here. Excuse the fact that I have inconsistent capitalization. All right, so we have reserves. Now let us figure out the slippage. So for slippage, we're going to have the day. We're still going to keep token 0 and token 1. Basically, all of these columns up here. All right, so token 0, token 0 address, token 0 symbol, token 1 address, token 1 symbol. We're going to have our reserve 0 of the day, our reserve 1 of the day, and then we have our amount 0 simulated, amount 1 simulated. All right, now let's add our new columns. So let me add a select. And from reserves. All right. So we're going to say, all right, how do we figure out what the slippage is based off of how much is going in? Did a bunch of Googling around. There's a bunch of derivations for this. So I would say that a good example for understanding the slippage in general is if you go to YouTube and search up this video. Lisa does a great explanation on AMM math, but our simulations are a little more complicated because we want to capture the fee as well. So I'm going to use this formula that someone has nicely derived in this GitHub, Dunjay Park, Dayjun Park, excuse me. So we're going to copy this in, right? It looks like it's the fee times our input, right? So we have fee times our input, which would be the amount 0 simulated. And then we have the reserve of ETH. So that's reserve 1. And I'm dividing that by the USDC reserve, which is amount or reserve 0, plus the total minus the fee of, what was the last one? Of the input again. All right, so let me just add parentheses around everything here so that it is consistent. And this is going to be as output simulated trading from token 0 to 1. All right, this is how much you're actually going to get when swapping token 1 to token 0, or token 0 to token 1. All right, so I'm going to take the same thing here and just reverse the 1s and 0s. And then this is swapping from token 1 to token 0. Obviously, we want to get the quoted prices as well. So what we can do is we can take amount 0 simulated and multiply it by the reserve price of 1. So how much you're getting out for how much you're putting in, basically. That's just how ExchangeX works. As quoted 0 to 1. And let's change this to output supposed, just so the naming is consistent. supposed 1 to 0. And I'm going to change this to 1. And now this, I'm seeing how much I get out of 0 for every 1. All right, so this is our outputs. Something that would be nice just to sanity check things is I'm going to join on prices.usd. And we're going to have that join on blockchain equals Ethereum. And minute equals day. And also we want that the contract address of the price is equal to the token 0 address. So we actually need this twice. So I'm going to alias things here. Why do we need it twice? We need the prices for both token 0 and token 1 at this time, just so we can have a good comparison to see if we have errors somewhere. And this would be on the token 1 address. And so let's just place this in here. We have p0.price as price 0 and p1 price as price 1. Let's select all from this. All right, it ran. Moment of truth. Let's see. We have our prices of our tokens, the output supposed, and then the output simulated. All right, so it looks like the outputs are very close. All right, so that means we didn't completely screw up. Now the price is price per token, right? So what we want here is 0.0997 or 0.997 times 1,000, which gives us 999, right, is the price of what's going in. Okay, so if we want to check the prices against the actual, something we should actually do is amount 0 simulated multiplied by p1.price divided by p0.price as prices supposed 0 to 1, and I realized I spelled supposed wrong here. And let's just do this for the other way around as well, so we can compare things more accurately. And what I'm also going to do is, just to make this run faster, we're going to do where block time is greater than now minus interval. Let's just say 6 months. Or 6 might be too short. Let's say 10 months. And let's run again. Month, not months. All right, our query has run. Let's see if this matches up. I have clearly mixed up the prices here. Where is it? This should be the 0 price on top. So for amount out, we should have gotten, let's see, we're simulating 2,000 or 1,000. Right, so it should be 1,000 times 1263 divided by 1 would have been price 1 over. So we want the other way, which gives us the supposed is 0.79. The token quoted was 0.78. The simulated is 0.782. You can see that this is already confusing to compare. So let's just reorganize things so that it is less confusing to compare. And we will run it one more time. Okay, cool. So we have it again. Let's just compare this in a line chart at this point, where we have the prices supposed, the output supposed, and then the output simulated. You can see they almost match up exactly, but every single day there's a little bit of a difference, right? So that kind of tells you, like, okay, for the actual price on like a centralized exchange, you would get 0.81 ETH out for 1,000 USD. The quote you would have gotten on Uniswap is 0.804, and after slippage, you would have gotten 0.802. So we have a few more steps before we're done. We're going to want to parameterize the simulated amounts, and we want to be able to get percentage slippage. So we're going to finish those two, and then we're done with today's query. All right, let's finish this off. So here we hard-coded it. I'm going to put this as amount 0 simulation. I'm going to put quotes around it. And then we're also going to do amount 1 simulation. Or amount 0, since this is USDC, we're sticking with 1,000. For this one, we're gonna, we have to change this to number. So this one is just gonna be 2, because this is ETH. Let's make sure this is a number. All right. And so we have this. Lastly, we do percentages. So percentage slippage as. And in this case, we want everything from slippage base. Except now, let's take speed.all. We also want the output simulated over output supposed, right? As slippage 1, 2, 0. So this is telling us out of the expected amount we were supposed to receive, how much did we actually get, right? And it's always going to be a lower percent. You can't get more than you're quoted. So let's change these. Right, so this is going to give us like 99% or 98%, so we need to do a 1 minus here to give us the actual slippage amounts. Right. So we're going to select from this, and we should be done. Cannot apply varchar. Let's see. I think this is thinking it's a text, so let's remove those. Okay, so our query has run, and it looks like this still is correct. I'm just going to call this as, move this around. This is going to be prices. What did I do here? Prices 0 to 1 comparison. And we're just going to make this like 5 decimals. Right, so we can kind of see the differences. If we look at our query results, we should now see there is kind of a slippage percentage here, right? So what we can do is we can now figure out what the slippages are. So in our case, this is percentage slippage for given simulated amounts. All right, so we can see, all right, slippage is pretty low for what we're simulating over time. It's like 0.3% on each trade. It looks like it's gone up marginally, so I need a few more decimals here just to see what's going on. Yeah, it looks like it's been going up very, very slightly over the last 8 months or so. By like 0.002% has been the increase in slippage. Now, obviously, slippage is going to look different for the pairs based off of what you put here. It's always going to depend on that. Let's also make a visualization for the reserves, just so we have it. Total reserves. And we have reserve 0, reserve 1. Let's enable a right axis, put reserve 1 on the right axis and say reserve 1 notional, reserve 0 notional, 0A, 0.00A, 0A, 0.00A. And cool, we can see the reserves of each token over time. Obviously, when one reserve dips and the other increases, that's because the price of WETH is changing, right? So naturally, the reserves are going to change to reflect the prices because of the swaps. So with that, we are done with day 10.
Thank you, Andrew, for that amazing walkthrough. I definitely learned a lot about slippage in this Corey walkthrough. So for bonus point, try to think about a smarter way of figuring out simulated swap amounts. So you could use 1, 2, and 3 standard deviations from the average that Andrew used in the Corey and simulate all 3 of those.